Hi, and welcome back. In this video, we're going to talk about the rules for operations on significant figures. The first one is when we multiply, so I'll write this down. First is for multiplication or division, and this is what we're going to be doing. You'll see we're going to be doing this most often in this playlist with chemistry. Is we're most often going to be multiplying and dividing different numbers and figuring out significant figures that way. And it's actually we'll see that this is actually pretty easy to keep track of. But all you're going to do is you're going to carry the least amount of sig figs. So let's say you had a problem where I don't know. Let's say well, I guess let's just create a few arbitrary numbers. Or how about let's just do arbitrary numbers. Let's say for some reason I had to multiply 0.0046 times, let's say, 1.27801. So let's say I had to multiply these two numbers together. How many significant figures would I have? Well, I'm going to carry the least amount of significant figures. And we can see that we've got, in this number, these are all going to be trailing zeros. And then we're only going to have two significant figures in our 0.0046. And then in this figure, all of these digits are going to be significant. So we're going to have 1, 2, 3, 4, 5, 6. So we've got two sig figs here. We've got six significant figures here. So we're multiplying the two of these numbers. So we're just going to carry the least amount of significant figures. So we're just going to have two significant figures. So let me get out the calculator. There it is. Okay, so let's say we have 0.0046 times 1.27801. So that's going to give us 0.005878, and we're only going to report two significant figures. So we've got two leading zeros here, and then we've got 0.587. So let me ask you this: is this what are we going to write down? So we've got 0.00587. Are we going to write down 0.58, or should we round up? And the answer is we should round this up. Because this 7 is a 5 or above, we're going to round up. So we're going to round up this other digit. So we're going to have 0.0059. So this whole thing is going to be 0.0059. And that's what we would write down. If we were going to write this down in scientific notation, how should we write this down? Well, we would say 5, write a better 5. So we have 5.9. And our decimal place is going to move 1, 2, 3. So we would have to move our decimal place 3 spaces to the right if we were going to write that down. So we've got two significant figures, and our decimal place moves 3 spaces to the right. So both of these final answers have got two significant figures. Both would be right. As usual, though, probably the best way to write down most of the answers that you get in chemistry really is going to be using scientific notation. So anyway, that's our first rule for multiplication and division. The next rule, give myself some space, the next rule is for, so I'll say this is rule 2, is for addition and subtraction. And what you do with addition and subtraction, it doesn't necessarily deal with the decimal, or it doesn't deal with the significant figures directly. It deals with them more in terms of the decimal points. And what we are going to carry with addition and subtraction is we are going to say that we are going to carry, so we carry the least amount of decimal places, least amount of decimal places. So that means, let's say we're adding a couple of numbers. Let's say, I don't know, for some reason I had a let's say I had a 1.587 gram sample of, I don't know, aluminum, let's say. And let's say I was adding that to a 2.6 gram sample of aluminum. How would my result look? Well, it doesn't, you can see it has a little bit less to do with significant figures. All we care about is how many decimal places we have. All we care about is the least amount of decimal places. So if we were going to add these two numbers together, so we would get, what would this be? This would be 3, so this would be 4 point, this would be, what would that be? It would be 1879, I think. Let me actually, I recently recorded another video where I made some big mistakes, so I'm just going to check myself real quick. 1.587 plus 2.6. Yeah, 4.18187, and that's, I misread that. That's not a 9, that's a G for grams. So if we were just going to multiply this straight out, we would get 4.187 grams. But because of our rule, we carry the least amount of decimal places, and so therefore our answer should only have one decimal place. And our significant figure here is an 8, so we're going to round up. We're going to round this up to 4.2 grams. And that's how we're going to represent our number. Let's just do another one of those examples. Let's say, I don't know, let's say I had 1.28 grams, and let's say I subtracted out of that, I don't know, 0.576 grams. So what would that be? So that would be, we would only have 2 decimal places. Even though each of these has got 3 significant figures, our answer is only, and this one has got 3 significant figures. Both measurements have 3 significant figures. The way we are going to report this is by taking the least amount of decimal places. So let me get out the calculator again, and I should be able to do these in my head a bit better, but 1.28 subtract 0.576. So we get out 0.704. So we get 0.704 grams. The only thing, though, is that we can only have 2 decimal places. So even though we started out with 2 numbers that each had 3 significant figures, our final answer is only going to have 2. And remember that this 0.70, this 0 isn't significant, right? Because this is a leading 0, but this 0 is significant. So we are going to have 2 significant figures. So this is, I guess, maybe a bit of an interesting case, interesting for dealing with significant figures, where we started out with 2 numbers that each had 3 significant figures, but when we subtracted them, we got a number that only had 2 significant figures. So anyway, so we had 0.70 grams. And also notice this number was a 4. So if we had, if this number had been a 5, let's just say, let me see. If we had said that, if this number had been, actually, you know what? I'll do this in another example over here. Let's say that we had done a separate example where we had 1.28 grams, and then we subtracted from that 0.575 grams. So this should be, let me just get out the calculator again. So 1.28 subtract 0.575. So we get now 0.705 as our answer. So we get 0.705. But again, we're only going to have two decimal places after places after the decimal point. So we're only going to have two significant figures. And we saw that in this previous example, this figure that we had to drop, this was a 4, so we didn't round up. But here, this number is a 5. So what we're going to do is we're going to round up. We're going to round this, our least significant figure, we're going to round it up 1. So what we are going to report is 0.71 grams. And it's two significant figures, but more importantly, because we are subtracting, it is going to be it's going to be two spaces after the decimal point. So those are the two rules to remember. And let me just state those again. So the first one is for multiplication and division. And this one, we just carry the least sig figs. We just carried the least sig figs. And for our second, which was for addition and subtraction, we carry the least decimal places. Least decimal places. And really, 95% of what you're going to be doing in chemistry is going to be multiplication and division. And even when we start talking about dimensional analysis and conversion factors and stuff like that, I'll definitely talk about easy ways to think about the significant figures in multiplication and division, because that's really going to be 90% of what you're doing in a chemistry course. Is you're always going to be multiplying or dividing by things, not so much adding and subtracting by different things. So anyway, I guess I'll end this video here. In the next video, I might make a short video just on rounding these significant figures. And then in the next video, I'll start talking about dimensional analysis and conversion factors and just some other general concepts that are good to have a high level of understanding of going into a chemistry course. So anyway, thanks so much for watching, and I'll see you in a future video.